Okay, now in this example, we're going to be converting 4,579, as it would be written in our numerals, that is Hindu Arabic, into Babylonian numerals. Now the thing is, when we're going from Babylonian, or any number system really, into our own number system, all we have to do is look up the values of the symbols used, check what place they're in if it's in a positional system, do all the math, add everything together, and get our number. And so it's fairly straightforward. But when we're converting from Hindu Arabic into Babylonian or some other number system, we're going to have to divide by how many groups go in the bases. So recall that our number system is base 10, meaning this 9 is representing 9 groups of 1. This 7 is representing 7 groups of 10. This 5 is representing 5 groups of 100. And this 4 is representing 4 groups of 1,000 because it's going by powers of 10. 1, 10, 100, 1,000, and so on. The Babylonians use base 60. So we're going to need to go a little bit through this system. So if I have 60 to the 0, that's 1. So that's the 1's place. If I have 60 to the 1, that's 60. So no problem there. If I have 60 squared, that's 3,600. And now if we do one more, let's go out to 60 cubed. That's going to be 216,000. And that should be enough. Now you could keep going, continuing to just multiply by another 60 to get the next positional system. So what we're going to have to do is look at this and look for how many batches of these different groups we're going to need. Now, 216,000, we're not going to need this, and the reason for that is that if I look at the number I have, 4,579, 216,000 is way bigger than this number. So what does that mean? It means that I'm not going to have any groups of 216,000. I'm not going to need to say 2 groups of 216,000 plus, etc., because that's already way too big. But 3,600, that's smaller than the number I have here, and I can definitely make some groups of this. So how do I figure out how many 3,600s fit into 4,579? Well, how many times does one number fit into the other number? By definition, that's what division is. You're seeing how many times the number you're dividing with goes into the number you're dividing into. So we're going to divide 3,600 into 4,579 to figure out how many groups of that we need. So looking at this, it looks to me like there's going to go in once. And how can I know that I did that right? My remainder at the end should not be bigger than what I was dividing by. So let's give this a shot. If this goes in one time, then 1 times 3,600 would be 4,579. And now I subtract. So I get 9, 7 minus 0 is 7. 5 minus 6, well I need to borrow over here. So 15 minus 6 for 9, and 3 minus 3 is gone. So I'm going to make a note now, before I get confused later, that I've got one group of 3,600, so I'll just put that right there. Now, 979 is my remainder, but I'm not going to do 9 groups of 10 and then 79 ones or something like that. That would be ridiculous. And also wrong, because this is 900. So even that would not work. It would have to be 7 groups of 10, and then I've still got these 900, which the Babylonians don't have a symbol for. Remember, left wedge represents 10, down wedge represents 1. So, 979. Well, I took care of the 3,600, but 60. Does 60 fit into 979? It sure does. How do I know that? Because it's smaller. So if we try this, if we take our remainder and divide it by the next position, the next number, it's going to be 60 divided into 979. So I'll just do this division. 60 goes into 97 once. So I get 60, and if I subtract this, I get a 37. Bring down the 9. So 60 into 379. Well, I know that 6 times 6 would be 36, so 6 times 60 would be 360. 36 with a 0 stuck on the end. Now if I subtract this, I'm winding up with 19. So I'll make a note of that right now. I need 16 groups, because that's my result, that's my quotient up here, of 60. And then I need 19 And I would go to the next position. I would divide this number into my remainder, just like here I divided 60, the next position, into 979. But remember, this position is 1. So do I really need to do 1 divided into 19? No, I know that's going to be 19. When you divide by 1, you just wind up with the number you have. So by doing the division out like this and taking the remainder and doing repeated division, we get that we're going to need 1 group of 3,600, 16 groups of 60, and 19 groups of 1. So the video is about to speed up while I erase this to make room for writing this number out with Babylonian numerals. So now, let's use these numerals right here, the left wedge for 10 and the down wedge for 1, to write this Babylonian numeral. So I need 1 group in this place. So 1 down wedge in the 60 squareds place. So that's just right there, 1 in the 3600 or 60 squareds place, just as a reminder. Then I have to include a space so that you know that I've moved into a different position and go here to the 60s place. So how am I going to write 16? Well, that's going to be 10 plus 6. So I'm going to say 10 and then 6 ones. So just as a reminder, that's 10, 1, 1, 1, 1, 1, 1 for 6. And this is in the 60s place. 60 to the 1, which is 60. Then again, I need to leave a space so that we know we've moved into a new position. And so right here, I need 19 groups in the ones place. So 19 is just going to be 10 plus 9. And that's just going to be 9 ones. So 1, 2, 3, 4, 5, 6. Running out of room a bit. Well, no, I can fit that in. 7, 8, 9. Okay. So that's 10, 1, 1, 1, 1, 1, 1, 1, 1, 1. Just as a reminder, this is in the 60 to the 0 or the ones place. So I just put these markings here as a reminder of what this means. But this part right here, just the left and down wedges, is how the Babylonians would have written down and recognized on sight the number 4,579. And that is this example.